So today we're going to be focusing on waves, and more specifically interference and superposition of waves.
We're going to be doing some demonstrations to help you better understand what waves do. Let's get started.
So a wave is a transfer of energy. So I'm going to drop a coin into the water, and the water is the medium in which we see the energy, and the energy is coming from the falling coin.
So here's the pan that we dropped the coin into. We'll represent the coin with the circle being the source of the waves. So when the coin hits the water, it emits its energy outwards in all directions. How we represent this energy is by waves in the form of circles, with the lines of the circles being the crests of the waves, or the tops, and the spaces in between being the troughs of the waves. The waves are going outward in all directions from the source. When they hit the pan walls, they reflect backwards in the exact same formation, and the energy keeps transferring until it is completely damped out.
So now that you have the technical terms, we're just going to do the demonstration again. It's important to mention that the pan is a fixed barrier, which means that when the waves reflect backwards, it's going to be inverted, meaning the crests are going to be the troughs and the troughs are going to be the crests now.
There are four properties of waves: reflection, refraction, diffraction, and interference. We are going to be focusing on interference, which is the resulting pattern due to the superposition of pulses.
There are two types of interference, constructive and destructive. Constructive is when the added amplitude is larger than the original, which would be a crest plus a crest or a trough plus a trough. Destructive is when the resulting amplitude is smaller. An example would be a crest plus a trough.
So here we have drawn out what the demonstration that we just did with the pan. These two dots represent the coins that we dropped into the pan, which are the sources of the waves. We have the waves drawn out, the lines being the crests of the waves and the spaces in between being the troughs. The waves go out in all directions from both sources, and here in the middle we can show the interference between the two waves. When two lines overlap, that is a crest meeting a crest, and it is considered constructive interference. Same with the spaces meeting the spaces, or the troughs meeting the troughs, which is also constructive interference, because the positive displacements of the crests add up to form a greater amplitude for the new wave, and when the troughs meet together, the negative displacements add together and form a greater trough, or a greater, deeper amplitude. Where we have a line meeting the space, or a crest meeting a trough, we have this on all sides, it is considered destructive interference, because the positive displacement of the crest combines with the negative displacement of the trough, and we momentarily have a net displacement of 0 at these places. It's important to note, though, that the waves do not entirely cancel in these spots, because if you think about the wave carrying the energy can't just go away. What happens is that the waves are just allowed to pass through each other without any sort of greater amplitudes being created.
Alright. So to get a closer look at constructive interference, we want to introduce a new term, superposition. So when we have a crest on one wave, and the amplitude is y1, and then there's another crest on that same wave, and the amplitude is y2. In order to find the amplitude when they superimpose, which is y, we simply add them together. We hope you have a better understanding of superposition and interference from our demonstrations.
Gee, physics really gets me excited about life.
I know, let's go study.
Okay, quadrille.